Good afternoon, all. This is A.S.M. Raju. Presently, we are dealing with respect to third unit in the mechatronics subject, and lively we are in the topic of sequencing hydraulic circuits and its working. Initially, moving on with respect to the sequencing circuits, as we have been discussed in the earliest class, that impartation of pressure and release of the pressure to some extent indeed to operate the system in a safe operating conditions or safe pressure accessory conditions. For that, pressure relief valves plays a major important role to leak the pressure which is having additionally than the set limitations that will be getting opposed instead of entering into the system or major circuit which is performing the activating positions. And later on, instead of releasing the pressure, you are being diverting the already existing pressurized fluid to the another system directly or parallelly, indeed to perform both the actions in two different circuits simultaneously. So by this, the imparted pressure will not be getting damaged, will not be decreased to cutoff region. There is no need of discharging the additional pressure which is entering into the single circuit. Commonly towards the second circuit also, the pressurized fluid will be getting entered, and with the impartation of single pressurized conditions or installation of the pressure head in a single unit can supply the entire power to two different actuators indeed to work in a live session. Coming to the point of these sequencing circuits, in many of the applications it is necessary to perform the operations in a particular order which has been framed as per the chronological order. So the components of the particular system which are designed as per the hydraulic strategy, it is commonly will be having the oil reservoir and filter, and the hydraulic pump, it acts as a prime mover which will pump the fluid within pressurized conditions to the system, and pressure relief valves which will act as an leakage of the small or minute amount of pressures which keeps the entire system to be in unsafe operating conditions. And integral check valves will be placed here for sequencing characterization. So the main motto here it is sequencing will forward the controlled pressure towards its forward direction or else the in the return stroke of constraint. Here, coming to the point of the sequence operations, the cylinder and piston arrangement indeed to perform the slow action, the controlled pressure of hydraulic fluid is being sent from the initial input stage of the system to the actuator indeed to commence a slow movement. Gradually, simultaneously, it can be altered in the counter case also. That is nothing but other direction of the cylinder and piston arrangement. So, for example, it is a cylinder and piston arrangement. The fluid with an high pressure is being entering here is being sequenced. So this is the setup, this dotted line internally having this sequence wall, which the highest pressure will not be entered or let into the actuator indeed to commence the corresponding movement. Either it may be a rotary kind of movement or else the linear kind of movement. In the pictorial representation, we are having the linear kind of movement, that is extension stroke and the contraction stroke. So here we are having F1 and F2 as a two different sequences. Here F1, F2, G are acting as an the sequence walls, and D is an inlet sequence wall which is controlled before entering into the circuit system. So how we can know, we will be knowing that what is the input system and what is the output system. So input system is the circuit which is before the directional control valve. So this is the directional control valve which is operated with solenoid control, spring return, hydraulic based. There is four ports, three positions, 4 by 3 way valve, directional control valve which is operated with an solenoid, spring return on double ends. So before this DCV, whatever the system that is having with respect to our circuit design, that is called as input system. Nominally, the system which is crossing this directional control valve and operating this actuator. So the right side towards the directional control valve, it is the output system which creates the actions in the output actuators. So first initial step, that is pressing the push button, pressing of a push button to start cyclic process, the shift the valve E, nothing but first type of valve. So here push button in the sense nothing but switching on the solenoid valve. So solenoid is nothing but the electrical power supply that is given at the input end. That is first position. By pressing that first position of this DCV will be coming into the force. So initially, without pressing in the sense, nothing but this ideal position will be in existence. And in the ideal position, we all aware that almost from the reservoir, the oil which is pumping, that will be connected back to the reservoir again. So that is the condition in the case of first condition. So moving on to the second condition, moving on to the second condition, that is either switches of operating, that the actuator tends to move in a forward direction or else in the return direction. So coming the initial stage, that is nothing but DCV which is operated in the first one, that creates the input, that is nothing but forward movement to cause the or to create the forward motion in the cylinder piston arrangement. So at this time when we switch on this, the fluid will be letting entering into the channel. So we'll be having a detailed look here. So why these sequence policy has been arranged here? Is there any need of arranging these many sequence walls here or not? So indeed to commence the work parallelly in two different activities. So clearly observe here, J is one cylinder and piston arrangement. H is another one more cylinder and piston arrangement. So for this, if you observe commonly, commonly if you observe, there is an input passage. So this is an forward stroke input line. Have a clear cut look. Forward motion. So with this forward motion, one sequence wall is being arranged here, and outlet of this sequence wall is entering into the inlet of this J. That is first actuator. Commonly, an mutation point has been existing at here, point number A or point A, which is again splitting in the forward direction with respect to that particular channel line to pass the motion in the second second actuator also. So this is entering into here, and this is the sequence valve, and operating into the output of the sequence valve is connected to the actuator. So commonly two different actuators are actuating simultaneously with the impartation of single input to the system. So that is the first condition. And commonly these output channels will be connected. So this is the output at an from an J actuator, commonly from H actuator also. It is commonly connected, and next it will be entering to a same channel which is being or coming out of the J channel. So it will be entering here, will be draining towards the oil reservoir in the forward stream. Simultaneously, if the directional control valve changes its position, there is nothing but second position coming to the force. So this will be the second position coming into the force. So this is the second position coming into the force. So connections are different. So initially it's forward, this position will be highlighting, and presently this position will be highlighting. So neutral position, this is the neutral position that is being considered, and this is also the forward that is connected here, and we'll be having a clear cut look in the forward condition. So in the step A, forward on forward conditions, what will be getting happen. So step A, if you have been switched on this position, first position of the DCV will be getting yellow, and fluid will be entering into this. Nothing but what is the change that is being taken place, we'll be having a clear cut look. When the push button start the cycle and shift the directional valve P to the position as shown in the figure. This position will be identified. At first, the fluid flows to the integral check valve of G into the cap end of the H and returns. So first one, integrally it will be flowing towards the G and enters into the cap, and then it will be getting returned and returns freely through the check valve within the F2. So it will be getting returned. So outlet, when fluid is entering into the forward direction, already entered fluid within the cylindrical piston arrangement at the other end will be letting move here, and hence there is no any connectivity because arrow mark is showing here and will be entering here. There is no any obstruction in the check valve. This fluid will be getting flown commonly here. So that is the condition. Next one, the pump pressure is low during this period. At that particular time, pump pressure is very much low. Only to the extent of pushing the load on H. Only because of to impart the pushing pressure, there is nothing but inlet pressure, indeed to cause the extension condition in the H. H is nothing but cylinder and piston arrangement here. So that is the first step that we will continue in. And commonly we need to have the motion in the J also. So without returning back, the same fluid which is entered into the H cylinder and piston arrangement have to be utilized for the movement of this J also. How we will be having a look. So once H reaches its rod end, nothing but it has been extended. This is a piston end, this is a rod end. So extension position has been completed on the rod end. The pressure builds up, and now the flow depends through F1, flows through the F1. Nothing but after completing the extension, there is no any movement that is being created indeed to extend here. So hence it obstructs. Initially it will obstruct here, and after completing this extension, there is no any movement that is required to cause here, and commonly ultimately the entering pressure or pressurized fluid will be definitely entering here, and next it will be acting towards this movement, but here check valve opposes, there is no any movement of the fluid, and next it will be entering here, and next sequence will be maintained. The compression will be taken place by the pressurized conditions, and because the pressurized fluid is connected towards this G also, but G has been already entered free flow and complete extension has been completed, and hence there is no any forward motion. Hence it obstructs. It is being filled out and being entering here. It is an obstruction. There is no any flow. Commonly it will be entering here, and hence the compression constrains within the spring, and the sequence creates. So upon creating this sequence, the fluid enters into the J. So when J is fully extended, completely extended, pressure increases furtherly and it limits by the setting of D, nothing but the D valve. So the extension will be getting taken place, and obviously it will be getting giving the signal towards the setting pressure, that is D, which provides the overhead production to the nothing but if completely it has been extended in the both the conditions, that is H actuator and the J actuator. Initially H will be moving in condition because of its free flow, which doesn't opposes any flow movement that is being occurring, and in the return stroke it will be having a condition, and initially it will be entering into J, and next over the history will be having a look in detail, and that is the condition of the forward extension. So after completing initially in H, and next the overall pressurized fluid will be filled out, and hence in the J, sorry, in the J has to be taken place. So F1 sequence involved will be coming into the actuation, and the sequence will be created, and hence this J also will be going on in a completely extended position that will highlight or energize the D sequence valve, which will safeguard the inlet pressure, nothing but switching off the pump. And next one, what will be the condition? Step C will be having a detail. When the other solenoid valve E, nothing but, is energized, the directional control valve shifts to the position shown in the figure, and the pump delivers the directed through D, E, and F2. So here I'll be having a detailed look. Again, this electrical switch or directional control valve switch will be getting retracted, or here get the signal that a complete extension has been taken place, and for that this D will be getting energized. So because of this D, the fluid operated conditions will be monitored in the DCV. Because of this D sequence valve, this directional control valve also being monitored. So it highlights in the E section, that is directional control valve in a second position. So this is the second position. So this position will be coming into the place. So what will be getting highlighted here? So D and E and F2, rod end of J, rod end of J will be entered as before. The flow out of the cap end of J flows to tank through F1, E and C, E and simultaneously C, and hence it obstructs the chip valve, and step C is illustrated here. So clear cutly we will be having a detailed look. I'll be showing with respect to the diagram. So second position is highlighted after complete extension. Here in the step B, after complete extension of this initially H and J, the D will be getting highlighted, and B pressure will be commonly connected. Same fluid supply towards the DCV first channel will be getting stopped. Now these connections are initial in strategy. These connections will be shifted to this position, third position. Just have a look at the step C. So step C. So here the connections from here to it has been shifted to here. So here we'll be having a detailed look. So fluid will be entering towards this channel. Presently, initially direct connections are taken place in the first categorization, and presently now it is being entering into this section, and initially it will be entering into the F2, right? Initially it is being entering into the F2. So here F2, it maintains the section, sequence section, so it obstructs the fluid. High amount of pressure will be getting entered. Initially there will be a free flow here. The obstruction is being taking place. Hence, high amount of pressure need to be generated. But here, a common connection is being taking place for the J also. Hence, there is no any sequence opposing pressure here. Sequence is nothing but opposing pressure, right? So, the freely flowing fluid will be entering from this channel to J first before entering this F2. After crossing this F2 only it will be entering into the H. But here sequence fall, it is obstructing the flow. So high amount of pressure when it has been created, then only it will be entering. So it will be entering initially with a free flow towards the J, and this causes the backward movement in the piston J, and initially it retracts back to its piston end, that is retraction stroke, and the fluid will flow nominally without causing any inconvenience towards the pressure, because it is a flow transfer condition only. It will be entering towards this, and next from this the fluid will be entering into the forward condition. But here is opposing in strategy. Forward will not yet be maintained in the sequence because return stroke is being taking place, because entering fluid pressure is not at all existing here, because the position has been changed from 1 to 3, and directly it will be drained back towards the output channel. Commonly, after the complete retraction of this, because after the complete retraction, there will be opposing condition towards the entering pressure here, and that pressure also will be letting in towards this. So here the obstacle will be existing for the flow, because check wall has been uh, existing here. The same fluid will be entering over this, and hence this compression will be taking place within the spring. The sequence get into the force. So the set pressure it is 5 bar of pressure. Let us assume. So this 5 bar of pressure will be completely considering in the case of this tension existing in the spring. 5 bar of pressure limit set. When it has been reached the set pressure, the sequence will come into the force actuation, arrow mark will be coming into the connection, and this fluid flow will take place through the H, right? And next, at this particular point, the backward movement will commence to start, and the piston from the rod end to the piston end, it will be start moving. At this particular section, the highest pressure is being entering here. So indeed to cause the slowest motion here will be changing the position of the check valve. So if there is any free flow like this in the F2, directly the speed movement of this piston will be taking place in the retraction stroke. So to oppose that particular pressure, indeed to operate the safety conditions in the system, if the pressure is being obstructed with respect to an check valve, and hence the same pressure which is being maintaining, that will be imparted with respect to the compression in the spring. And if that pressure has been set limited, if it is 5 bar of pressure is being entered and 3 bar of pressure is being maintained in the spring, so only 2 bar of pressure will be as a difference. The 2 bar, if it is maintaining slowly, the draining will be considered. So from the J, if the fluid is being retracted, so there is no any actuation of the sequence wall in the return stroke. Normally the fluid will be drained back towards this channel, and the return stroke also there is no any here there is an obstruction. So by creating highest pressure at the output channel of the H from the F2 sequence wall, the obstruction has been created here in the G sequence wall within our check valve. So this valve will energize, and that return stroke fluid will be delivered back to the oil reservoir. So this oil reservoir, there is a small minute mistake that has been considered, that check valve will be in opposing in nature, because this check valve have to be in reverse condition, because free flow has to be taken place for draining into the oil reservoir. There is a mistake in the diagram. So here this is the free flow, this is the obstruction flow, and this is the free flow. So here instead of inverting, it has been specified here. So inverting, this is the diagram, and this one. So already entering fluid will be returned back to the drain back to the oil reservoir. That is the step number C. That is nothing but the sequence conditions. So observe clearly in the step A, B, and C. So initially, when it has been connected in a forward directional strategy, after the complete extension that has been commenced in the, we'll be having a detail look, completed in the H cylinder and piston arrangement, then only the extension taken place in the J. So in the return stroke, it is reverse. Initially returning back the J, and later on it is being entering into the H, because because a free flow of movement has been taken place in the forward direction directly towards the H piston and cylinder arrangement, which causes the free extension. After causing full extension, there is no any allowable vacuum or volumetric conditions to enter the fluid furtherly in the cylinder and piston arrangement of this H actuator, and hence that pressure will return back towards the F1 sequence valve, which is being opposing with respect to the check valve here, and finally the sequence valve will come into the force by compression taking place in the spring, and sequence will create and set pressure will be entering into the J. So that is the condition in the first step that is being taken place. So forward stroke లో అయితేనేమో H రిజిస్టర్లో హెచ్ యాక్చువేటర్లో ఫార్వర్డ్ స్ట్రోక్ అనేది ఫస్ట్ జరుగుతుంది, అండ్ జేలో వచ్చేసరికి టైం సెకండ్ ఎక్స్టెన్షన్ జరుగుతుంది. అండ్ కామన్లీ ఇన్ ద రిటర్న్ స్ట్రోక్ అది కంప్లీట్ ఎక్స్టెన్షన్ జరిగిపోయిన తర్వాత డి విల్ హైలైట్స్, అండ్ నెక్స్ట్ commonly if it retracts back, nothing but retracts back second in the second position, the third position or return stroke position will be coming into the force, and this will drive this fluid in a reverse direction. So reverse direction lo vachesariki initially the fluid will be getting entered into the J first, and after the complete return stroke back in the J, then it creates the opposing pressure within the entry section of the DCV, and hence the sequence valve F2 will be coming into the force, will create the back pressure, nothing but return stroke in the H actuator. So that is the return movement will be taking place. So that is also in a control strategy because of the actuation alignment consisting in the G sequence valve. That is the condition being taken place. So this is the sequence condition that is being taken place. Right. Next, we'll be moving on with respect to the step D that is being taken place. After the complete retraction strokes, again the cyclic process need to be in condition. So for these particular conditions, the on completion of the step number C, nothing but pressure will be getting increased once again in the case of this step C after the crossing of step C. So complete retractions of H will be J will be considering first, and H will be taking place, and the return strokes will be completing completing in the two different actuators, and it is ready for alignment, nothing but giving the signal for this particular pilot conditions towards the J, that the DCV need to be changed in its position. So what is the DCV change positions? So after the complete retraction strokes initially in the J and H will create the lot of head pressure without getting entering the fluid in the for backflow of conditions, and hence this give the signal towards the from B to D, and D will be getting highlighted, and this D will retrieve the conditions of changing its directional control valve to its normal positions, nothing but the ideal position, or else again towards the forward direction it to need to be taken place. It will be carrying towards the forward direction. So this is the sequence way of controlling the forward and return strokes for both loading and unloading conditions spontaneously in the industrial fields without any involvement of the humans. External force actuations or external force is not required for operations, because automatical section, while it operated automatical section from the D sequence wall towards the pump actuation B, which is directly pumping the fluid from the oil reservoir channel head, which is the C, is continuously taking place for both the forward actions and return actions. But the sequence walls are being existing indeed to control the flow as per the requirement. In the given circuit diagram, we are being finding out that initially in the forward stroke, the H is being considering its motion, and after completing this, J is being existing in the forward direction. Vice versa, commonly, if the positions of this sequence walls has been interchanged, we can change that particular movement of actions also, because instead of creating first extension in the H, we can create that extension J also, because of replacement of this particular sequence walls. And this dotted line is nothing but the sequence wall. So check valve and connection linkage sequence walls. So this sequence wall direction will be changed from left to the right, and this check valve, which is opposing pressure towards the back, will be extended towards the right, and hence this sequence valve will be coming into the force. And here for this cylinder we have to interchange this left side direction has to be taken place into this side, and here this left side directions opposing should be replaced towards the right side opposing, and hence interchanging of this G to F1 and F1 to G creates the forward motion first in the case of this J, and later it will be entering into the H if the sequence also G and F1 has been interchanged. But what will be the backflow? So simultaneously backflow also, then here backflow first will be creating in the case of this H, and later on will be moving with respect to the J, because of the alignment uh, or arrangement of this particular sequence was taken place. And furtherly is an power losses in flow control circuits. So what is meant by power loss? So power loss is nothing but at the directional changes or crossing at different elbow levels, or directional just changes at the control valves, and even the diversions of fluid from one alignment to another alignment, and shifting of the fluid by passing through the pressure relief valves and directional control valves, and then finally reaching towards the actuators, leads to a minute losses of pressure with respect to the fluid or within the fluid. So the passage or rational movement of the fluid will be getting into decrease. So decrease of pressure in the sense nothing but velocity of the fluid will be getting increased in its movement, but it will be limiting to some extent here in this case. So limiting here in the sense nothing but the dropping of the pressure which is already imparting by the prime movers, nothing but the motors. So in such a way, what range as per the components that are being arranged at the different levels of circuit system or circuit design conditions, whether it is being decreasing in a less amount of strategy, or leakages or pressure drops are being occurring in a high amount of strategy. That plays a major important role. So what is the situation if the pressure has been dropped? So if the important pressure, nothing but indeed to operate the output actuator, for example, if we need 5 bar of pressure, if the or power losses or pressure drops are nothing but the power losses. Power losses will be considered. So if these power losses has been considered or pressure drops has been considered, obviously at the end actuator which is need to be operated with respect to 5 bar of pressure will be decreased. For example, if 1 bar of pressure has been dropped due to the nothing but these power losses, then instead of generating 5 bar of pressure at the actuator, only 4 bar will be circulated. So this 4 bar of pressure will not be sufficient for driving that particular actuator in a prescribed timely basis. For example, extension of that particular stroke need to be commenced within 2 minutes. But if ఎప్పుడు జరుగుతుందంటే 2 minutes లో if 5 bar of pressure is being supplied, but here power losses జరిగితే 1 bar of pressure డ్రాప్ అయిపోయింది అనుకోండి, ఓన్లీ 4 bar of pressure మాత్రమే ఎంటర్ అవుతుంది. But it will take more than 2 minutes of time for this extension then. So finally our output will get damaged. So these power losses affects the output actuators, so either in the linear form of the movement or else in the circular or angular form of the movements that are being conditioned or taken place. So in what way that is being considered, why those power losses will be considered, will be having a just a glance for this. So energy losses in the current hydraulic systems ranging between 30% and 50%. This can no longer be accepted, and therefore relevant scientific research carried out in the last 20 years has analyzed the main causes, which vulnerable places in the installations, and ways to reduce them. So here, almost the power losses will be or might be getting happened because if one pipe to another pipe has been joined with an gasket, so gasket is nothing but the leakage group. The two different pipes has been joined with respect to flanges, nuts and bolts arrangement, and maintaining with a gasket. So due to the environmental conditions, this gasket may be getting roughened, or else this may be getting destroyed, and automatically small minute leakages will be exposed to the atmospheric conditions. So from that, one drop, two drops, like that, the leakages will be getting happen. So due to that, the power losses will be getting taken place. And not only that, if the directional changes has been occurring, I think but DCVs need to be changed in its forward and return strokes. So for that, an accumulator which stores the temporary storage of pressure in containing fluids will be utilized furtherly for compensation activity of this minute power losses considering in the operational sector. So those are the rectification processes that are being existed. So what are the minute steps that are being taken place? We will be having a look. In fact, energy losses are determined, among others, by the friction of the fluid layers between them and with the pipes through which they passes, and by the pressure drops in the equipments at bends and diameter changes. Just now that we have been discussed. Nothing but ఒక స్ట్రైట్గా ఫ్లో అవుతుంది ఫ్లూయిడ్, అక్కడ రైట్ సైడ్ టర్న్ అవ్వాలనుకోండి, వెళ్ళి హిట్ అయిపోయి అక్కడ జాయింట్ దగ్గర మళ్ళీ రైట్ సైడ్ తిరగాలి. సో వెన్ ఇట్ హ్యాస్ బీన్ గాట్ హిట్ అట్ దట్ పర్టికులర్ directional change or bends at it, bends that has been discussed here, bends and diameters, and smaller diameter to larger diameter, and larger diameter to smaller diameter, nothing but nozzle kind of situations. Small diameter to highest diameter, and highest diameter to the smallest diameter. At this particular range, the pressure will be getting increased when it has been reduced from large to shorter, and shorter to larger in the sense it will be getting decreased, and shorter to long, longer to shorter, it will be getting increased in strategy. So finally, all these cumulative hydraulic pressure losses turn into a heat format. So generates the temperature, and thus to the energy loss is also added the destructive action of the high temperature and the obligation to introduce additional cooling equipment in the system. So it leads to a high temperature development and might be causing the restriction, increasing of the safety operated pressure, and increases the uh, unbearable pressures within the equipment setup, and this causes the power losses. So, for these conditions, what are the cooling factors that need to be taken place, and for that, what are the components that are need to be placed within the systems that we'll be discussing detailedly in the next class. Thank you.